Ways a volcano can kill you. All right. First thing, lava. Obviously, if you jump into some lava, that's not going to end well. Now, so lava can kill you. There's some different types of lavas. These that I'm going to show you for a quick second are basaltic lavas from Hawaii, and I just focused on that because I was there and it was pretty cool. I saw 2 out of 3 of these types. Pahoehoe, it's pronounced pahoehoe. It is a Hawaiian word with respect. Please pronounce that correctly. Anyway, it flows faster, and when it piles up, it looks like coiled ropes. Then is said to be clinkery. When we're back together, I've got some of these lava rocks. I can clink them together and you can hear the clinks. Hence clinkery. But also it's chunkier. It's more viscous. It does not flow very fast. Here are some dudes walking away from lava. Seriously, you just walk away. It's hot and maybe a little uncomfortable being that close to it, but you just walk away. The chances of this killing you are minuscule. I mean, yeah, maybe you got something else happened to which you passed out, so then you weren't able to walk away. Anyway, it's not going to kill you. Now, it might destroy your home, but it's not going to kill you. And then pillow lava, it's called that because it's all round on the outside. This is just lava as it enters the water and cools rapidly like that, and so forms these pillowy shapes. Now, go and watch the Volcanoes playlist I have for you, and there's actual moving videos of these types of lava. That's a lot more interesting than me even talking about it. But, all right. Anyway, the chances of lava killing you are surprisingly slim, so let's just move right along. I mean, honestly, you have to go put yourself in harm's way, really, to be killed by lava. It's just not going to happen. Particularly, we're here in Indiana. Of course, it's not going to happen. So, the next things that could kill you, and these are all explosive eruption products. So, this type of eruption. This can cause some serious problems. This, meh. I mean, you'd have to be standing right there for that to be a problem. This, can get you far and wide. Okay, so the first type of explosive eruption products, just general pyroclastic material. Pyro, I know you guys know this, means fire. Clast refers to chunks of rock. That would become more familiar to you if you ever do something geology class-wise. But anyway, pyroclastic material just means fiery rock stuff. So different sized particles ejected from a volcano and that are non-lava related things. So ash, cinders, which are about this size. I mean, they're typically whatever you would think of as a rock, as a cinder, if it's, popping out of a volcano. Lava bombs are bigger. Here's a lava bomb. I drew in what would be like the size of a soccer ball, just for relative size of the idea of that lava bomb. A lava block would be something more like the size of a piano, or maybe like a VW bug. Now, these things can cause some serious problems. First of all, because they're extremely hot. We're talking 600 Celsius, or for you Americans, 1400 Fahrenheit, 873 Kelvin. For us science nerds. Anyway, but really hot. Okay, so that's gonna not be comfortable if you're stuck in it. Now, the cinders, the lava bombs, and the lava blocks don't travel that far from the magma. Really, the cinders particularly stay right there by the volcano, and kind of like, if this is the volcano, they just sort of pop right out and land right there, and then actually just increase the size of the volcano. They make the volcano steeper and taller. But that's kind of like for the same reason the lava's not going to get you, the cinders are not going to get you, because the chances of you being right here when that happens, no. So you don't have to worry too much about cinders. Now, as though there can be lava moving in closer to an area, and then the closer the lava is to where the people and things are, then the more worrisome we are worried about things like lava bombs and lava blocks, because those can pop out. They get all the, the gas from like water underneath there that evaporates and then just sends them flying. These things can go pretty far, like football field or two. But again, you're probably not going to be even that close to the lava in a situation like this. But now, should something like a lava bomb hit you, it's probably going to break some bones and, be really hot, so singe you as well. Something like a lava block, if it actually landed on you, would be like a car or a piano landing on you. Yeah, you crush you to death, but also it's really hot, so that would not end well. But okay, even still, those things are unlikely to be the case. Now, a pyroclastic flow, there is one of the videos of that in the volcano playlist I have for you, but you can see that stuff like trailing down the volcano, and it moves pretty fast. That would really hurt because of how hot it is. And the ash falling on top of you could be a problem. Like after it, goes up in the air and falls back down, this can also be problematic, particularly if you have asthma, COPD, breathing kind of problems, but also really hot ash falling, not so great. Now that is going to cool somewhat, so it's not necessarily going to incinerate you, but it can be very thick when it falls and so suffocate you. Okay, but now speaking of ash and pyroclastic flows, Pompeii in 79 AD. How did this happen? I'm pretty sure most of you are Vesuvius familiar with this. What's a V? Anyway, that's Mount Vesuvius is the name of the volcano. And now how did this happen? So by the way, this happened in the month of December. There are absolutely records about this because there are several towns on that island, and it was only Pompeii that got completely wiped out. The other towns are perfectly fine. Now, it's also of note that look at how these people are. Like this one is still laying down. Here's the head. This one is just starting to get up. This was very early in the morning. And that happened when these people were killed. And the way we see what we're seeing here is when they unearthed Pompeii, like archaeology, that kind of stuff, excavated it out. They found these open spaces, these cavities in this rock. The rock type was made from the ash that had collected. Anyway, and so they poured plaster in those spaces and then chipped away the rock, and they found things like humans and horses that were running in the field and stuff like that. Okay, so now here's how it happened. This thing called a Nue Ardante. This is a type of pyroclastic flow, a very specific type of pyroclastic flow. Now, you see we've got 6 steps here of how this one happens. Step 1, tons and tons and tons of hot ash into the air. Thousands upon hundreds of thousands of pounds of this hot ash. Now, then there has to be a sudden pause in the eruption. There has to be the pause because while there's the eruption going on and the ash cloud is in the air, there is the continuing updraft, if you will, the continuing explosive power of the eruption happening underneath that keeps all of this stuff up here. Well, if there is a pause in the eruption, which we're not entirely sure why that would happen, but it can. So like that just goes away. Well, there's no longer that mechanism holding up all this ash cloud, so it just whoop, falls very quickly. Now, another thing to know, as it is falling, what happens in the air right by it is in the air, like this could have been a perfectly clear, blue, beautiful sky kind of a day, but there is water vapor in the air. That's these dots, okay? Now, as the water vapor in the air gets trapped underneath the ash cloud, what will happen is the water vapor gets smushed together. And as that water vapor gets smushed together, it eventually turns into liquid water. So now we have this really hot cloud of ash that just whoomp onto the ground, onto the side of the volcano, with this cushion of water underneath it. That cushion of water becomes this very slippery mechanism for this ash to just really crazy fast come down the side of the volcano. And we're talking 100, 150 miles an hour. You are not outrunning this. You're not out driving it. You're, quite frankly, most likely planes and such wouldn't even outdo this unless they're already in the air. But once it starts, nope. So then what happened is this incredibly hot cloud of ash, okay, like 1400 Fahrenheit, traveling at 100, 150 miles an hour, just instantly whoop into the town of Pompeii, burying, suffocating, and incinerating these people and the animals and everything there. Now, the bright side to this is it would likely be a very quick death because that is so hot. It would very quickly burn your nerves so you wouldn't feel it. And it would be so suffocating that I can only imagine their nervous systems are burned. They can't feel it, but hopefully it was all just over very quickly. So I just say, if this ever happens to you, I can't even, I don't want to imagine. And the problem is that I can't imagine, but just take a quick breath and get it over with. Take a quick breath of hot ash and just get it over with. Oh, this is really bad. Really bad. Whew. Now, sometimes the question is asked, why were there people living there in the first place? Well, this was 79 AD. They didn't know it was a volcano. And the volcano, in its previous eruptions, had put out ash here, which becomes very lusciously fertile soil to grow your crops and everything. Life was really good in Pompeii. Really good. Until this happened. All right. Next thing. A volcano could actually drown you. What? Drown? That means water. What? The volcano producing water? Well, yeah, because just like I was explaining up here, when that ash cloud goes into the air in this otherwise perfectly clear sky day, or maybe it wasn't already a perfectly clear sky day, but that ash cloud displaces the water outward, and we can get very serious cloud development, like storm cloud development on the edges here. And these vertical clouds are the storm clouds, the cumulonimbus clouds, the clouds that produce very strong thunderstorms. So actually, yes, an explosive eruption can cause the kind of storm that can cause lightning that could technically kill you, but it also is going to produce very heavy rains. And those very heavy rains are going to be up on the tops of the mountains and mixing with the hot ash and produce very hot, very fast moving floodwaters. And this is something called a lahar. And when this happens, the ash has already fallen. Some ash has already fallen. Ash cloud condenses the water to give us those heavy rains, and then that all moves together for very deadly type of flood. Now, this is something that would be able to be avoided. In most cases, would be able to be avoided if you were in the area when this happened, because you know what, just watch the video of the lahars and you'll see actually people standing kind of close by, because like, oh, there's the river, so that's where it's going to flow into. Now it's going to exceed its banks, but unless your home is like right there and unless you didn't evacuate, like you probably won't fall into this. But if you do get into this water, it's hot, so that's uncomfortable, but could be like a hot tub hot. I don't, it depends. But it's going to be very fast moving. I mean, the kind of thing that even, you know, Olympic gold medalist Michael Phelps wouldn't do well in that kind of water. And it will pick up all sorts of debris along the way, be that, you know, trees and stuff, or buildings, cars, whatever. So it will drown you and beat and bash you. This is not going to be pleasant. Okay, the next thing is something called Phreatic Activities. Is that the last thing? Well, sort of. Okay, phreatic activity. This can happen where there is basically magma under the ground, but closer to the surface, and then some kind of like a bog or like a swamp sort of area. And then that basically creates these flash, boom, steam in these kinds of boggy areas. And it's hot steam and ash. And so it could basically kind of boil you, really. But then also suffocate you after it comes out. Now, these are also called cold pyroclastic surges. Cold is just a name. It's still going to hurt. This is colder than it actually is coming out of the volcano. Like the volcano is somewhere like way in the background. This is just an area nearby. So it's called cold, but it's only colder than the volcano. It is not actually cold. And no es bueno as to whether or not it can get you. Now, all right, last thing here. Super volcano. All right. Yellowstone is a super volcano. Now, in a normal year, good times, we would watch this whole video about all this stuff. Basically, a super volcano is a much, much, much bigger version of an explosive eruption volcano than has happened in recorded human history. These have happened, but not in recorded human history. So way long before there were, conscientious humans walking around, writing things down and talking about them. So now there are several of these supermassive supervolcanoes on Earth. The nearest one to us is Yellowstone. And I don't just mean, name one of the volcanoes in Yellowstone. No. We mean like the entire Yellowstone area. There's this gigantic magma chamber underneath. Gigantic magma chamber. Let me see if I can... this is my personal iPad, not my school iPad, so I don't even know where... Oh, there it is. There's Google. Yellowstone magma chamber. Okay. Super massive, and were it to erupt, because it will, by the way, it definitely will. Oh gosh. Here is Yellowstone National Park. There's the magma chamber underneath it. It's just, it's really big. Anyway, would we be safe here in Indiana? Well, folks with breathing issues, probably not. I mean, like ash would reach as far as Indiana. What of the previous things mentioned would be a problem? We could have this happening. We would absolutely have lahars happening. The new Ardante, possibly, only if it's had any kind of momentary pause in the eruption. That would not happen to us here in Indiana. We'd be too far for that to happen, but this still could happen. Any of this amount of stuff, yes, and this would be a lot more widespread than we would think. So as before, I'm talking about the cinders, the lava bombs, the lava blocks. That would definitely spread over the whole Wyoming area, all of that stuff near Yellowstone. It is very unlikely that we would get anything like cinders in Indiana, but we would definitely be getting ash. And this kind of eruption can actually, on a side note, or maybe not side note, this can create some climate change in the sense that it can put a sort of ash cloud in the air that could blanket half of the earth, and that might actually hang out for something like 1 to 4 years. And now think about what would happen then to climate in those 1 to 4 years if we have ash in the sky. So, I mean, the initial volcano itself would be really hot, but we might actually get colder temperatures because of blocking out sunlight for the next 1 to 4 years or so. And that would actually shut down a lot of the water cycle because there'd be less evaporation. So then conditions would likely become very dry in those years because we don't have the evaporation that leads to the clouds that leads to the rain. Now, there would be some amount of rain in those years, but not as much as normal. Those would be drier years, so the crops would suffer between blocked sunlight and dry conditions. And now you're also like, Huffman, you were just telling us how this kind of volcano could produce storms. Yes, like right while it's erupting. So within like the several hours or days while it's erupting, yes, heavy rains and floods. But for the next 1 to 4 years or so after, we would actually very likely have very dry conditions. This would not be good for the overall food economy on Earth. So on all those pleasant notes, volcanoes can kill you. Yeah. All right.